right, welcome back, everyone. We're going to go ahead and get started. Hope you had a refreshing break, gave your mind a quick rest, checked in on any messages you might have had, got a drink. So we're ready to get back to part 2 of our dam removal short course, and we're going to move into segment B. And this is going to focus on sediment risk assessment, sediment quality, and regulatory issues, presented by Ms. Susan Bailey. Ms. Susan Bailey is a research civil engineer at the U.S. Army Engineer Research and Development Center's Environmental Laboratory in Vicksburg, Mississippi. She received a bachelor's in civil engineering from the North Carolina State University and a master's in civil and environmental engineering from Louisiana State University. She also holds a professional engineering license for civil engineering in the state of Mississippi. She has over 15 years experience working with applied engineering and research related to sediment and dredged material management. Her main focus has been on contaminant and sediment transport and modeling to evaluate risk related to dredged material placement and management of contaminated sediments. She's also performing lab and field studies to examine the ability to model consolidation of dredged material placed for marsh restoration. More recently, she's been applying her background to sediment transport to issues associated with dam removal, which is what brings us all together today. So at this time, Susan, we can go ahead. I'll give you presenter rights and launch into part B.
Hi, Courtney. Can you hear me?
I do. Sound great.
Very good. Thank you, Courtney, and so glad each of you can join us today. So just real quick, some of the topics we're going to cover. Just briefly, we're going to look at sediment quality and how the impacts that may have. We're going to cover a framework for risk analysis and management, and then we're going to wrap up with a quick overview of regulatory considerations. So I kind of talked about the common management concerns with respect to sediment and how volume is a factor in the risk of sediment impacts. And so just briefly, I want to look at how sediment quality is also a factor. So sediment quality is a key factor in determining potential impacts, as well as management strategies and navigating the permit process. So sediment quality can relate to either physical or chemical characteristics, and some of these we talked about during the question and answer session earlier. Grain size is kind of an important one. Grain size, if it's deposited downstream, this can alter the grain size characteristics of the downstream habitat, and so it can result in some habitat degradation from that. For instance, fine sediment infiltration, where the fines deposit in between the gravel bed interspecies, can affect refugia as well as oxygen availability, so it can have a big impact. Turbidity is also caused by fine sediments, and those can have impacts on fish, such as gill abrasion. It could also reduce light penetration, which affects primary productivity. Grain size, as well as the level of cohesion, of course, can impact the erodibility of the sediment, so this can impact how the channel evolves through the reservoir. Also, the presence of contaminants we're going to talk about in a moment, but these can dramatically increase the cost for dam removal and lengthen the evaluation process. So that's really important. And nutrients also are a concern as they tend to accumulate in reservoir sediments. Okay, so now we're going to switch gears a little bit, and we're going to talk about how do we do this sediment risk analysis and management. And so the potential impact of reservoir sediments can range from negligible or they can be significant. So it's extremely important that we evaluate that risk so that we can make management decisions. We can balance the level of protection and associated expense with the level of predicted impact. So there's a set of guidelines that have been developed for assessing the risk associated with sediment and determining appropriate management alternatives. And these guidelines were developed through the Subcommittee on Sedimentation by our friends at the Bureau of Reclamation, and those include Jennifer Boundary, who took part in last week's webinar, and also her colleague, Dr. Tim Randall. And so we're going to walk through this framework that's provided by the guidelines. So as you can see from the figure on the right, this kind of gives us an overview of this risk evaluation framework. You can see it includes a series of iterative steps for data collection, analysis, and management evaluation. And these guidelines are developed in an effort to match the level of data collection, analysis, and management to the estimated level of risk. And that's because management techniques, as well as the data collection and evaluation process, all of that can incur significant costs and time. So it's important that we try to minimize that level of effort to the extent possible. So the process starts out with assessment of readily available information and then works through the steps to progressively collect more quantitative information as needed. So the risk is largely dependent on the volume of sediment, contaminant levels, and the potential for downstream impacts, of course. And so the guidelines provide detailed guidance for conducting each step of the analysis, and we're just going to walk through these steps so that we have a feel for what might be involved in the evaluation. So the first step is to identify sediment concerns. It's also important at this point to clearly identify the project objective. For example, why is the dam being considered for removal and what outcomes do we hope to achieve? At this point, we want to develop an initial conceptual model, and that's going to be based on just what information is readily available, and that's going to describe how the reservoir landscape might respond to dam removal. So this is going to include the extent of upstream erosion, as well as the downstream fate of eroded sediments. If there's potential concern for contaminants, then we also want to identify contaminant transport pathways and receptors of concern. So available information at this point might include things like observations from a site visit, aerial photographs, or topographic maps. And it's also important to have discussion with stakeholders at this point so they can help identify sediment concerns. So there's a long list of potential concerns, and we're not going to go through all these, but these basically boil down to the common concerns that Kyle discussed earlier and that Jennifer discussed last week. So these concerns need to be evaluated for impacts both upstream in the reservoir area, as well as to the downstream river and to the receiving water. So, and of course, we also need to investigate the benefits at this point. Some of those are listed here. So the next step is going to be to collect some baseline data that's going to be needed for the risk evaluation. So the existing data should, of course, be synthesized first, and then reservoir and river data may need to be collected to fill in those data gaps. Existing data might include bathymetric surveys or topography, any sedimentation studies that have been done, or sediment gradation. And then site reconnaissance can be used to document physical conditions, such as the long list listed here. And it's also important that the conceptual diagram that we developed in step 1 be used to identify locations for data collection and should be modified as information becomes available. This reconnaissance and this conceptual diagram should be used to understand how the river is currently functioning from a geomorphic standpoint, and then how we expect that to change once the dam is removed. So also knowledge of the dam history and previous reservoir operations can also help us to estimate the sediment volume and distribution through the reservoir. A reservoir sediment survey is going to focus primarily on estimating reservoir sediment volume. So as Kyle talked about, you may need an initial probing survey to create a map of sediment type and depth. But for significant sediment volumes, you may want a bathymetric survey of the reservoir pool, as well as topographic survey of the exposed sediment. So, also, Kyle talked about the importance of pre-dam topography, but that may also be very difficult, maybe a challenge to collect that information. The spatial distribution and size gradation of the reservoir sediment should also be described to the extent possible. And then sediment mass may also be important, and we can estimate the mass based on the volume if we know the bulk density or have some estimate of bulk density of the sediment. Some river channel data may also need to be collected, and this is going to include the river profile and downstream slopes, as well as the stream bed composition, topographic survey of the channel geometry, and extent of the floodplain. So as we discussed previously, the presence of contaminants within the reservoir significantly impacts the risk associated with releasing those sediments downstream. Just to give an example, when the Fort Edwards Dam on the Hudson River was removed in 1973, reservoir sediments contaminated with PCBs were released downriver. So this resulted in impacts to water quality, aquatic habitat, and it required long-term cleanup efforts, which required dredging 2 million meters cubed of sediment. So we want to avoid any actions such as that. So it's really important that we sufficiently evaluate the potential for contaminants. So as with the previous step, available data should be first reviewed to determine if sufficient information is available to make a decision. A due diligence assessment is performed first to determine if there's reason to believe contaminants may be present. So this involves looking at surrounding land uses. So what's the surrounding activity? Would any of those activities result in contamination, such as, for example, mining activities or industrial activities? Any reason to believe we may have contaminants. And if there's no cause for concern, and if the sediments are less than 10% fine, then contaminant testing is not necessary. But if you do have reason to believe, or if you have a significant amount of fines, then you'll need to develop a sampling plan. And the reason for the percent fines is that fines, of course, tend to attract contaminants to a much higher degree than coarse sediments. I also want to point out here that many states will omit the due diligence assessment, and they'll automatically require some degree of testing. So we'll need to develop a sampling plan, and guidance is provided on how to collect samples, where to collect samples, how many samples to collect, so you could consult the guidance for that. They give a lot of good information there. And these sediments are going to be analyzed to determine if the contaminant concentrations exceed sediment quality criteria and background concentrations. If contaminants are present, then it has to be determined whether or not they can be safely released downstream. And so this is going to depend on the significance of expected impacts and whether these are expected to be short or long-term impacts. In addition, biological analyses can be done to evaluate effects on biota using either sediment bioassays or bioaccumulation tests. A nutrient test can be used to evaluate effects to the water column. And you should consider the relevant pathways, whether it's if we're interested in what deposits in the channel or if we're interested in the water column, or both. I also want to point out that it's important to work out this sampling and analysis plan with the regulatory authorities. It's going to be a large part of that, so they should be involved at this point. Also important to consider what are the receptors of concern. So, the obvious ones are listed here. And then, depending on the significance of the predicted impacts, special management actions may be required, such as either stabilizing the sediments in place or removing those sediments, or other options such as capping to isolate those contaminants from sediments and biota. Okay, so next we're going to look at the volume, and Kyle discussed various methods to estimate the volume of sediment in the reservoir, but the question is, how significant is that volume? So this is going to depend on, how much sediment the stream normally carries. So what we want to determine is the relative reservoir sediment volume. And so this is the ratio of the sediment volume in the reservoir to the average annual sediment load. So this basically gives us the number of years' worth of sediment load stored in the reservoir. And once we have that, we once we have that, we can estimate the probability of impact associated with that volume and classifying it as either negligible, small, medium, or large based on the logarithmic scale shown here. For instance, if you have 1 to 10 years worth of sediment, then you would say you have a medium risk. If it's less than 1/10 of a year, then you would say it's negligible risk. And if we look back at the flow chart, so we have that on the right, then if we have negligible sediment, then we're done with the sediment analysis. But otherwise, we need to move on to the next step and refine our risk estimate. So recall that sediment risk is the product of the probability of impact as well as the consequences of those impacts. So in the previous step, we looked at the probability of sediment impact, but now we need to assess the consequences of those impacts. So these consequences are going to be assessed qualitatively. We already listed those concerns in step 1, but now we want to refine those. Now, our consequences are going to depend on both the magnitude of the impact and the duration, as well as the potential for recovery. So consequences can also be ranked as small, medium, or large. For instance, small consequences might be cases like in an undeveloped area where there's no infrastructure or property to be impacted. Medium consequences might be more temporary consequences, and then large consequences might entail impacts to property or infrastructure or threatened and endangered species. So it's important to consider the long-term benefits also, because these may offset some of those short-term consequences. So combining this probability with the consequences gives us the overall risk, as you can see in the table here. So once we have a pretty good idea of the risk associated with this list of concerns, then it's time to determine our alternatives for managing those risks. So last week we talked about some of the mechanics of dam removal and processes that might be involved, and you can certainly go back to those webinars if you wish. We're going to kind of touch on that here as well. Some of these management alternatives can incur significant costs. So deciding what management alternatives are needed need to be based on the risk posed by the sediments. So if you were able to listen last week, you'll remember that we talked about dam removal. It can, in most cases, we're talking about removal of the dam in its entirety, but in some cases, only a portion of the dam may be removed. Part of it may be retained either as for historical preservation or to retain sediment as a management technique. The lower portion of the dam may be retained as a grade control, or it could actually be retained as a barrier to exotic species if that's one of the concerns. We also talked about 2 ways to remove dams. They can be removed rapidly, in which case most of the sediment is released in pretty short order, or it can be a phased removal with incremental reservoir drawdown, where layers of the dam are removed gradually over a period of time, and this can reduce effects from releasing a large volume of sediment downstream. Timing is something else to consider. For example, timing releases during high flow events may reduce biological impacts. Also important, if there's any erosion-resistant materials, such as remnant structures, those may need to be removed because those can affect channel migration. Also, the reservoir drawdown should be planned so that it doesn't cause downstream flood damage or induce bank failures. So we have some control in our dam removal plan as far as managing risk. We also talked about some sediment management alternatives, and there's the no-action alternative, which is actually leaving the dam in place. One might decide that the sediments, for instance, are overly contaminated, and it would be a huge risk if we try to remove the dam, so we're just going to leave the dam and the sediments in place. So that's one alternative. Outside of that, we have 3 basic management alternatives, and the first of those is river erosion, where the sediment's allowed to just naturally be eroded downstream. This results in the greatest amount of sediment release downstream. But if that's an issue, if we expect to have severe consequences from that sediment being released, then we may select other management alternatives that prevent release of that sediment, either by removing it or by stabilizing it in place. For example, mechanical removal might be selected as an option where sediments are contaminated or if otherwise impacts are not acceptable. Also, sediment can be stabilized in place by creating a stable channel either through or around the reservoir sediments in such a manner that those sediments are not going to erode. And also, vegetation and bank stabilization techniques can be employed to help stabilize that sediment. I do want to point out, though, that there's also a long-term risk associated with this because those measures could fail at some point. And I also want to point out that the same risk applies to the no-action alternative for leaving the dam in place. Okay, so once we have a plan in place for removing the dam and managing sediments, then the impacts related to dam removal can be predicted. First of all, we need to decide the level of effort that's needed to predict that risk. There's a broad range of assessment tools, and these range from very simple calculations, almost back-of-the-envelope type calculations, to very complex modeling that requires intensive data collection as well as time and associated costs. So the level of effort in determining the sediment analysis is based on the risk. And I don't want to go into too much detail on this because in part 3 of this series, next week, we'll give an overview of the assessment methods and application of several techniques. And then we'll have several case studies in both parts 3 and 4 that demonstrate some of these techniques. So I hope you can join us for those. So we also have to be aware of some of the uncertainty as far as our predictions. No matter what techniques we use, there's going to be some level of uncertainty. This uncertainty may be observational, where we're unsure about some of our measurements. For instance, how sure are we about our estimate of the reservoir sediment volume? Were we able to get measurements of the pre-dam topography, for instance? Also, did we collect enough samples that we have confidence in the grain size distribution or the contaminants tested? So we may have some uncertainty that remains there. We may also have some uncertainty about certain parameters that are used in the models, like hydraulic roughness, for instance, and we may have some uncertainty related to the models themselves. So for each category of our concerns, we need to assess the uncertainty that's related to those predictions. And so once we have our sediment impacts compiled and the predicted uncertainty, we need to assess the impacts of the resources of concern. And so we need to determine if those impacts and uncertainty are deemed tolerable. And so if those are deemed tolerable, then we can move on to the next step. But if they're not, then there's a couple things we can do. We might try to reduce some of that uncertainty. We may try to collect more samples or do additional analysis so that we have a little more confidence in our results. Or we may go back to the drawing board and revise the dam removal and sediment management plans. And then one other option that we might consider is mitigation options. As an example, if water quality impacts, for instance, were predicted downstream, then maybe we could install a new water treatment plant that could handle the high sediment loads either temporarily or permanently. Or we could also investigate other water resources. So as an example of where mitigation has been employed, mitigation was needed for the downstream impacts resulting from release of the sediments at Elwha and Glines Canyon dams in Washington. And this included construction of both water treatment facilities and flood control levees. And I also want to point out that the cost of these mitigation actions was 3 times the actual cost for removal of the dam. So mitigation is an option. It can be expensive, but it can be done. So finally, once we have an acceptable plan in place, then we'll also need a monitoring plan. Monitoring is typically needed for permit compliance, but it may also be needed for other reasons. For instance, we may want monitoring to make sure the project is carried out as designed. We may want monitoring to document ecological response, also to document whether or not the project was effective at achieving specific objectives that we may have had. And certainly if we're doing any kind of adaptive management, then we'll need monitoring for that. Of course, the extent of the monitoring plan is going to depend on the questions of interest and also the available budget. And it makes sense that the level of monitoring should also correspond with the level of risk. And some of the parameters listed here may be used to evaluate physical processes of interest. And again, monitoring may be important for permitting compliance. And so with that, we're going to switch gears from the sediment risk framework to look at some of the regulatory aspects. So looking more at our regulatory and permitting decisions, we can see that a lot of the evaluation that we've gone through, looking at various impacts, is also of interest to a number of regulatory authorities. So, for instance, Clean Water Act is important for both water quality and sediment discharges. Endangered species is of interest to Fish and Wildlife. We also talked a little about looking at historical sites. So there's a lot of regulatory interest in dam removal. So we're going to give a quick overview of some of the regulatory permits related to dam removal. So dam removal requires permits from both federal, state, and local authorities, and these permits are generally required to ensure the removal is done in a safe manner and to minimize impacts. So most dam removals are going to require a Clean Water Act Section 404 permit, which is issued by the Corps of Engineers for any activities that involve discharge of dredged or fill material into waters of the U.S. And the Corps will also issue a Section 10 permit for activities affecting navigable waterways. Also, if the dam is a hydropower dam, then the owner will need to apply to surrender the FERC license or issuance of a non-power license through the Federal Energy Regulatory Commission. Also, any actions by federal agencies may also require compliance with NEPA regulations. Smaller dam removals may qualify for nationwide permits rather than individual permits. Nationwide permits are designed to allow streamlined review for activities that result in no more than minimal adverse environmental effects. For instance, if a nationwide permit is used, then no additional NEPA would be needed to issue the 404 permit, for instance. The Nationwide 53 was implemented in March of 2017 for removal of low-head dams. And so that's the most important one here, but there's also some other nationwide permits that may apply. And it's primarily the decision of the Corps District Engineer as to whether the project is reviewed as a Section 404 individual permit or under the general or nationwide permit. Corps districts can also choose whether to revoke the use of a nationwide permit or can place regional conditions on its use. For instance, I think a number of districts have revoked the use of the Nationwide 53. Also, states or tribes can also include conditions in their 401 water quality cert to ensure water quality protection. We'll talk a little more about that. As part of issuing permits, either the Corps or FERC may need to conduct consultations to meet requirements of other federal laws. For instance, the Endangered Species Act requires consultation with U.S. Fish and Wildlife Service or National Marine Fisheries Service if threatened and endangered species can be affected. Also, under the Magnuson-Stevens Act, any action that may adversely affect essential fish habitat must consult with NIMS. And also, federal agencies are required to consider effects on historic properties, which may require consultation with the state or tribal historic preservation officer. In order for the Corps to issue a 404 permit, the state has to grant or waive a Section 401 water quality certification, stating that the dam removal activities will not result in violations of state water quality standards. Also, if the project has potential to impact the coastal zone, then the state must issue a certificate that the activities are consistent with the state's coastal zone management program. So each state and local government can have different permitting requirements, and of course that process can be rather expensive and time-consuming. And permits may be required relating to a number of things listed here, such as waterway development or dam safety or resetting the floodplain. Some states have published guidelines that can help navigate this regulatory process. Some states require individual applications for each individual permit, whereas other states offer a joint permit application package. So that can be useful also. And there may also be some local permits needed, some municipal permits. For example, for demolishing the dam structure may require a demolition permit from a local municipality. Also, a building permit may be needed for some activities, for instance, like construction of a copper dam. Dam removal activities, as we know, it can result in some adverse impacts. So requirements to mitigate for loss of wetlands upstream of the dam caused by its removal will depend on the permitting mechanism, the policies, and the guidelines of the applicable Corps of Engineers district. But on the flip side, mitigation credit may be considered for dam removal. The Corps Regulatory Guidance Letter, number 1801, provides some information on factors to consider when determining mitigation credits, recommendations for quantifying mitigation credits, as well as treatment of wetland losses from dam removal. According to the REGAL, restoration of streams that results from removal of obsolete dams should not require compensatory mitigation if those actions result in net increases in aquatic resource functions. So that would be a good thing. Okay, and so that's most of what I have. So Kyle started us off kind of looking at the volume stored behind the dam as well as potential concerns associated with removal. And then we covered a risk framework for evaluating risk associated with the sediment. And finally, we looked at how those concerns are addressed within the regulatory context. Outside of that, I hope you can join us next week so you can hear more details about some of the assessment tools for quantifying sediment transport. But at this time, if you have any questions on either what I presented or remaining questions for Kyle, then we can try to answer those at this time.
All right, sounds great, Susan. Thank you for the presentation. Any questions, please continue to submit chat, or if you'll recall, if you want to ask your question over the phone, please select #2. Larry just had a comment that salmon and steelhead ESA consultations are through the National Marine Science Fisheries Service, not Fish and Wildlife, and mentioned that they can be difficult to consult with in this regard.
Yeah, thanks for that clarification, Larry.
Larry Oliver wanted to know, how do we determine the best rate of sediment release? Are there studies of unaltered rivers that describe the natural amount of sediment in riverbeds in the absence of dams that we can apply to sediment release with removal projects? He mentions he would think that most of the rivers in the U.S. have been impacted by agriculture, which increases sediment input, followed by dam construction, which decreases sediment downstream transport, starving downstream areas of sediment. How do we determine the desirable amounts of sediment release when we remove a dam?
That's a very good question, Larry. So there has been some research on that, but not a lot. I think it's an area where we need additional research. We're trying to start a new work unit where we look at releases from reservoirs and turbidity impacts from those. So hopefully we'll learn more about that in some upcoming research.
Absolutely, and this is Kyle. I'll just add that I'll put in the chat a link to a paper by Alan Moll's team and a bunch of big thinkers on sediment regimes of rivers, thinking about what is the natural sediment regime for a river, how do we quantify it, how do we think about it, and how does it provide the context for these types of management actions like dam removal, like sediment bypassing of reservoirs. So I'll drop that link in the chat. But I think it's in the same vein as the discussion around what is the natural flow regime and what are flow targets. People are starting to think more in a more structured way about sediment regimes as well. So.
Thanks, Kyle. All right, any other questions for Susan or Kyle today? We'll spend a few more minutes here. You can chat those in. Any other questions on the phone?
We have no questions on the phone at this time.
Okay, I see a question from David Williams. Is there any concern on concentration of natural contaminants into the water column during release of stored sediment? I haven't seen anything specifically on that associated with dam removal, but I'm sure that could be a concern. Natural contaminants can be considered contaminants just like anthropogenic ones. But my general thought on that is that if you have natural contaminants, there's a good chance that the upstream and reservoir contaminant levels are going to be very similar to those downstream. That may not always be the case, but I would say there's a good chance of that.
All right, and then Susan, there was a kind of a follow-up statement to the NIMPS comment from Larry. Andrew mentioned that he echoes that sentiment of the challenge consulting with NIMPS rather than Fish and Wildlife. He wants to know whether you feel there's been a sea change amongst the regulatory community and environmental community more generally with greater acceptance for fast dam removal with high sediment loads, assuming no particular contamination issues.
I don't know that I've really seen a change. Of course, I'm not as intimately connected with the regulatory community as some, so if others, have a little more information on that, I would like to hear it, but from my perspective, I don't really know about that change.
And this is Kyle. I would say in my experience, it's a little patchy region to region. Some regions of the country still have pretty strong views surrounding the quote-unquote notion of sediment as a pollutant, and other parts of the country seem to be thinking more about these ideas surrounding natural sediment regimes. So I don't know that I would characterize it as a sea change, but I would say there are parts of the nation that seem to be more accepting of higher sediment loads in a temporary context, like dam removal.
All right, then Larry Smith mentioned most agencies seem to be more in support for dam removal. The NIMPS generally is looking for certainty and evaluating potential impacts that can be difficult or nearly impossible, he says, to meet. Oh, I'm sorry, I was muted. I was just mentioning Larry's comment there that NIMPS is also looking for certainty and evaluating potential impacts that can be nearly impossible to meet. Hank Yarbo wanted to ask, should adverse long-term impacts to shoreline vegetation around reservoirs be a consideration for dam removal?
I think that's a very good question. I would put that in the trade-off category. That occasionally there's a balance of communities that are interested in removing the dam versus keeping the dam, and I'll also throw into there the mix that I think you're alluding to of novel wetlands surrounding reservoirs, and to what degree those can and should be mitigated for. And yeah, there's kind of Pandora's box of both social issues and regulatory issues that come up with these novel wetland communities around reservoirs. So that's an excellent point.
All right, thanks, Kyle. Let's check in on the phone. Are there any other phone questions?
I'm currently seeing no questions on the phone. Again, that's #2 on your telephone keypad if you have a question.
All right, thank you. Okay, if you have any final questions, please go ahead and type those in. I'm going to go ahead and send a reminder that if you'd like a PDH credit, please send me an email, and I will record your attendance today and send you a certificate for each hour of the short course that you attend. All right, any final discussion or questions today regarding sediment management? All right, well, let's begin our wrap-up then. I do want to point out our topics for next week. We've got, we'll be continuing our short course that's talking about assessment methods of dam removal. So we hope you'll be able to join. That'll be next Tuesday, November 10th at 1 o'clock Central Time. Again, we'll send an invite with specific login instructions. I've got Kyle and Susan's contact information here if you want to reach out to them further about the topics presented today or others or other conversations surrounding dam removal in general. But Kyle or Susan, do you have any further comments for us today before we wrap up, or anything to say about next week's presentations as well? Kyle, I'll ask you first. Anything else?
Nothing specific, just thank you all for your time. And I'll note that we're in the process of putting this content together in an ERDIC technical report. So if you have any feedback that would help us shape that document on key topics you'd like to hear more on, please let us know. And that's something where you can still shape the research products as they're coming out. So thanks for your time, and we look forward to talking to you again next week.
Great. Thanks, Kyle. Susan?
Yeah, I just wanted to echo that, and thanks everybody for your participation today and your questions, and I can join us for parts 3 and 4.
All right. Well, thank you both. Participants, we're glad you could join. I did share one final link in the chat. It's a link to a 2-minute survey where you can provide feedback on our presentation today. And once again, it was good to be with you all today, and we'll look forward to hopefully learning with you again soon in the coming week. With that, we will conclude our meeting today. Have a good afternoon.